Now it's time to create a data set. So first I am creating the first column of the data set, that is the first component or the first column of the data set, and I am calling it as x1. So I am using np.array, and the values I am passing are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's run this cell. Let's see x1. So x1 is 0, 1, 2, 3, 4, 5, and this data belongs to numpy array. Let's see the shape of the data. So the shape of the data is 10. So it has only 10 sample. It is my 1D data. Now I can transform this 1D data into a 2D data without changing these values. So I have to use reshape. So I am using reshape on my x1. So the line of code is x1 dot reshape, and I am giving the input -1 +1. So if we use -1 and +1 in input, so what it will do? It will do two things. The first thing, it transform the 1D data into 2D, and then it transform the data into the form of the column. Let's run this cell and let's see x1 now. So you can see that that was the previous form of x1, and now I have transformed this x1 into a 2D, and that is our feature vector, or this is the column form of x1. So now if I want to check the shape, so the shape is now 10 by 1. Previously it was 10, so it was 1D, and now it is a 2D shape, that is 10 by 1. Now it's time to create the second column of our data. So I am again using np.array, and I am using the different value 201, 220, and the last value is 339. So let's run this cell and now transform this into a 2D, and let's see x2. So this is our x2. So this is our x1, and this is our x2. Now it's time to create the third column of our data. So I am again using np.array, and now I am passing different values starting from 2000, and the final value is 9776, that is 9776. And here, after creating, I am also reshaping in a single line of code. Let's run this cell and to see x3. So we have x3, we have x2, and we have x1. Now we will use these as a column in our data set. So I want to create the final form of my data. So I am using np.horizontal stack. I am stacking these x1, x2, and x3 and creating my final value or the final form of the data, which is the capital X. Let's run this cell, and now we can see the shape of the X. So this is our X. This is the first column of X. This is the second column of X, and this is the third column of X. So in this way, we have created first all these three columns, and then we have stacked them into the single matrix. Now we can also create the value of y using np array, that is the labels. So I have passed 10 different values from 10 to 100. It is 10, 20, 30, 40, 50 up to 100. So this is my y. So in this way, we have created our data set. We have created the value of x, that is feature, and we have created the value of y, that is label. Now it's time to split the data. For splitting, I am using the train test split function, and I am passing x, y, test size is again 20%, and random state is equals to 42. So this is the same line of code which we have seen in our project one. So let's run this cell to perform the splitting. Now it is time to perform the data standardization, both on the training component of the data set and on the testing component of the data set. So I will import standard scalar from scikit-learn.preprocessing. So this standard scalar will help us to standardize the data. So let's run this cell. So here it's time to instantiate this standard scalar, and I am call the variable as sc. Let's run this cell. So the first step is to fit this standard scalar to the training component. So what fit will do here? So in data standardization, fit will compute the mean and standard deviation to be used for later scaling. If you remember, in min-max scaling, the fit was used to compute the minimum and maximum value of the data. But for standardization, we do not need the minimum and maximum value of the data, but we need the mean and standard deviation of the data. So here the fit function is going to compute the mean and standard deviation of the data. Now it's time to transform the training data to the standardized form. So let's perform sc.transform here, and basically first we have to run this fit, and now I can transform. Okay, now the error is removed. Now I have transformed my training component according to the calculated mean and standard deviation. It's time to observe the standardized value of the training component. So we can see that this is our standardized form of the training component. So we can see that there is no feature which is dominating, and there is no feature whose magnitude is quite high as compared to other. If we go back and see the original form of our data, the third feature has highest magnitude as compared to the first and second. But after data standardization, all the values are close to each other. Now let's see the mean and standard deviation of the standardized data. So if we calculate the mean of this data, which is the standardized form of the data, let's see the value of the mean. So the mean is 0, and let's see the standard deviation is 1. So this is another very important property of the standardization. That is, the standardization has removed the mean from the data. That is, the mean value is 0, and the spread or the standard deviation of data is 1. So this is obtained after the standardization of the data. Now it's time to standardize the test data. We know that from the previous project that in order to avoid data leakage, we have to use only transform for the testing component of the data. So here I am transforming my testing data to the standardized form, and I am calling it X test scale. And we can see that this is the form of X test scale. So we had total test samples in our data set. We use 2 sample, that is 20% as a scaling, and we use 8 sample, that is 80% as a training. So in this project, we learned how to perform data standardization. We learned how we can create the separate column, and then we can use the important function, that is the horizontal stack, H stack, in order to stacking all the columns into a single data. So I hope you understood this project. Thanks for listening, and I will see you in the next lecture.